Hi, today we're going to learn lesson 3.1, day 1, and that's on understanding rational, exponents, and radicals. And we're going to take a look at how radical and rational exponents are related. In the first example, the explore is to take a look at where the powers come from. So anything raised 3 to the third power is equivalent to 3 times 3 times 3, and that's how we get 27. 3 squared is 3 times 3 with a 9, and 3 to the first power is just 3. And notice that when the powers get reduced, it's equivalent to dividing by 3. So you're losing a factor of 3, and it's equivalent to reducing the exponent. If we complete this pattern and keep dividing by 3, we will end up with a negative power. So notice that 3 to the, so from the 3 divided by 3 is our first negative powers. That's going to be 3 to the negative 1 or 1 over 3. And 1/3 divided by 3 is like multiplying by 1/3, so that'll give you 1/9. And so another way we can see that is with a negative power, we can rewrite it as a positive power. And that's going to lead us into the next property that talks about that. So we have two properties here. One is that anything to the 0 power is equal to 1, except the base cannot be 0. And the next one is anything raised to a negative power can be written as a fraction 1 over the positive power. And the question here is for discussion is how come in the second case for the first rule here that the bottom base cannot be 0. And that's actually kind of related to the second one because you're going to end up with dividing by the base. So you cannot be dividing by a 0. So you're going to have, end up with a 1 divided by 0, and you cannot do that. So therefore, that's why we have to limit the base cannot be 0. And let's take a look at our actual radical expression, and let's identify. We have this form, the radical form, nth root of a, and that's how we say it. The n is the index, that's how many roots we are taking. And then this is the radical sign, and a inside the number is called the radicand. So here's another representation of it. You can see it as a power form, which is x to the a over b power can be converted into this radical. So the number on the bottom goes outside, and then the number on top will be on the inside on top. So the short form that I would recommend my students to remember is what's on top stays on top. So if you can actually remember that, that's actually easy to remember. So what's on top will stay on top, okay? And there is an example here. Let's take a look. In the first example, 64 to the 1/3 power. So to understand that the nth root is actually a power, so that means the 3 is going to go outside. So it's equivalent to the cube root of 64. And we can rewrite the 64 root into 4 to the 3rd power. And notice that the cube root and the cube cancels each other out, so we just have 4 as the answer. So now we know the cube root of 64 is equal to 4. And in the next example, we have the 4th root of 81. Let's convert that into the root, the radical symbol, and that's the square root of 9. And we know that the 4th root of 81, well, we can rewrite 81 as 3 to the 4th power. And the square root of 9 can be written as 3 squared. And we can simplify the 4 and the radical root into 3 here. And the square root also cancels out the square. So we have 3 times 3, which actually 3 plus 3, which is 6. So the final answer here is 6. Here's a couple problems that you can try. So please go ahead and pause the video at this time so you can actually try the problems before you look at the answers. Hopefully you had a chance to try the problems first. Here are the answers. And the first one, 8 to the 1/3 power, that's equivalent to the cube root of 8. And we can rewrite the 8 as 2 to the 3rd power. And the cube root and 3 cancels out. And the final answer is 2. The next one, we can rewrite this half power as a square root and the cube root as a 1/3 power as a cube root of 27. And next is to rewrite that 16 as the square root of 4 squared. And then we will have the 2 and the 4, the square root cancel out. The 27 can be 3 to the third, and they will cancel out. So we have 4 plus 3, which is 7. In the triad problems, we're going to be naming the property that is demonstrated in each equation. So in the first one, we can see that we have a product of two numbers, 2 times a, and then the next step is we distribute that 2 to the fourth power, which is how we get 16, and then a to the fourth is 4. The property that is used is the power of the product. And the next one, we have actually the two powers get multiplied. So this is actually the power of the power property that we use. So those are the two answers here. Next, we're going to take a look at more computation problems. Here we have the number on the bottom represents the root. So we have the cube root of 8. And then what's on top stays on top, so we still have a power outside. And we know that 8 is 2 to the third power. And let's rewrite that and cancels out the power. The power cancels out the root. We have 2 to the second power, which gives us a final answer of 4. These are triad problems, so make sure you pause the video and try it first before you look at the answer. Next, we have a square root. So we have the square root of 25, and then what's on top stays on top. We have the third power. We know that square root of 25 is just 5, and then that's 5 to the third power, which gives us a final total of 125. Next problem is going to be the fourth root of 81 plus square root of 4, and we know that 81 can be 3 to the fourth power, and then square root of 4, we already know that is 2 squared. So let's simplify that. The 4's cancel out the fourth root. The 2 cancels the root. We have 3 plus 2 gives us a grand final of 5. Here are the answers again for you to review. And that is the next set of questions that we get to try. So let's go ahead and try the next set of problems here. Using the rule 1 to the anything power is 1, so we know that the answer for the first one is 1. Again, you need to pause the video and try the problems before you actually look at the answers. Next, we have a square root. That 2 on the bottom means square root. Square root of 9, we can either rewrite it as a 3 squared and then cancel out the root and the power, or we can just recognize that the square root of 9 is actually 3. Next problem, number 7, is the fourth root of 16 to the fifth power. Well, we know that 16 can be written as 2 to the fourth, and that will help us cancel out the fourth root and the fourth power, which leaves us 2 to the fifth, which is 32 as an answer. And number 8 is the cube root of 27. And that would just be 3 q to the third, which is 27, and we can cancel out the root, leaves us 3 as the answer. And we have a third root of 343 raised to the second power, and then 32 to the 2/5. That means it's the fifth root of 32 to the second power. So let's rewrite the bottom, and we know that 343 is actually 7 to the third power, and then 32 is actually 2 to the fifth power. So we got the roots cancel out the powers again. We got 7 squared times 2 squared. That's going to be 49 times 4, which is 196. And that's the final answer. And notice the last problem has a negative power. So we have to rewrite it as a 1 over positive 100 to the second half power. And that's just going to be a square root of 100. Or we can rewrite it as 10 squared. The square root cancels out the root, and we got 1 over 10 as the final answer. Or you can divide that into 0.1. So that's the final problem for Triad today. And here are the answers for review. And it is time to get started with your homework, which is book set for day 1, 13.1. And then HIW 3.1 to get started, and then copy notes for day 2. And don't forget you have Alex. And that's a wrap.